Okay, so ladies and gentlemen, welcome to the second installment in functional groups. Today we're going to talk about aldehydes and ketones. We're going to start off the same way as we did with alcohols. We're going to talk about what the functional group is for aldehydes. So the functional group for aldehydes is a CHO group, which is written as oops, sorry, CHO group, which can be written as why can't I? Yeah, CHO, or if you want to write the structural formula of the functional group, it can be written as C double bond OH. Now, the suffix that we use is Al, and there's something really special about aldehydes. They always get position number one. Position is always one. So we're going to do a few. Oh, you have noted this down. So you don't really have to number an aldehyde ever because you know it's always position one. Uh, Moving on. So let's do the names and the structural formula for a few aldehydes. The first one is methanal. So instead of OL, it's an AL. We did alcohols before this. So, and the structural formula is, so this is your aldehyde group. This is your functional group. And the condensed structural formula is HCHO. The next one is ethanol, which is CH3 CHO. Moving further, the next what? Okay, it's really sorry. I had to stop the recording because there was this spinning ball of beach ball of death, which made it really difficult to work. So okay, the next one is propanal, Propanal, and the structural formula for that is CH3, then a CH2, and then a CH double bond O, which is CH3, CH2, CHO. Propanal, and then last but not least, it's butanal, which is CH3, CH2, CH2, CHO. Okay, so I'll do a think pair share again on this question, which is why is it that small aldehyde molecules like methanol, ethanol, propanol are readily soluble in water, however big aldehyde molecules are not. So I'll give you 2 minutes to do a think pair share and then we'll start discussing it. Thanks. Small aldehyde molecules like methanol, ethanol, and propanol have one thing in common. All of them have very strong dipole-dipole forces. Because they're smaller molecules, you'd find that the dipole-dipole forces will dominate the dispersion forces because there are less electrons, and we know that the electrons contribute towards the dispersion forces. So you'll in small molecules, the dipole dp is much greater than dispersion forces, and in bigger molecules the dispersion dominates the dipole-dipole forces. And this is the reason that you'd find that the smaller molecules will be soluble in water, which has greater dipole-dipole forces, or soluble in polar solvents, which have greater dipole-dipole forces compared to dispersion forces. But aldehydes would be readily soluble, bigger aldehydes would be readily soluble in non-polar, because non-polar has greater dispersion forces. Now, this is no different to what we discussed in alcohols, but the only difference was when we talked about alcohols was that alcohols had hydrogen bonding, smaller alcohols had hydrogen bonding, but in aldehydes we do not have that hydrogen bonding because the oxygen is not attached to the hydrogen, or the hydrogen that is responsible for hydrogen bonding is not attached to the oxygen here. So what we'll continue from here, we'll go on to ketones in the next lesson. Until then, see ya.